at these two examples. Basically these are the average rate. We did some introduction to the average rate on our previous video, so in today's video we're looking at these two examples. You can go ahead and pause the video, try this on your own, but let's get into it. So number one, let's look at number one. Right, I hope you can see. Let me just zoom this in. It reads as follows: find the equation of the tangent line to the graph given by fx equal to x squared plus 2 at a point x equal to 1. Okay, so we have this parabolic graph here. Let me just sketch it. You have this parabolic graph. So this parabolic graph, of course, will bounce at this point here. That is not a good looking graph. Okay, there you go. It will bounce at 0 and 2, which is this point here. Now they say the tangent touches at the point x equal to 1. Now we know that a tangent is a line that touches a graph, or rather it touches a curve at one point, right? So this will be at x equal to 1. Now that is a x equal to 1, which is that point there. Now at x equal to 1, what will be my y value, right? So at x equal to 1, I'll take this 1 and then I'm going to substitute it there in place of my x. Therefore f1 will be equal to 1 squared. Whenever I see an x, I put a 1 plus 2, and then 1 squared plus 2, that is 3. So at x equal to 1, I have my y, which is 3. And then my tangent line, it won't be something like that, because now we have two touches. We'll have a touch there and then a touch somewhere there on the negative side. Remember, a tangent only touches the graph once, so meaning my tangent line will be something, oh my goodness, it will be something that looks like that, right? It will be something that looks like that. Okay, so now let us find the equation of the tangent line. We know that the equation of the tangent line is given as y is equal to mx plus c. Is basically a straight line function. Okay, so now the question is, how do I find the gradient? Well, remember we said that the gradient of the gradient on a point on any curve is given as the limit as h approaches 0. Okay, h approaches 0 of fx plus h minus fx all divided by h, right? This will be the gradient of the tangent line, or the gradient at x equal to 1. Okay, so now I can find the gradient in that case. Remember, what is fx plus h? Well, we are replacing x with x plus h, so meaning wherever I see x, I'll put x plus h, which is in this case is here. So and then we'll have 2 right there. So let me expand the bracket. Therefore I'll have x squared plus 2xh plus h squared plus 2. Okay, so now the next step is to find fx plus h minus fx, right? Remember, we want the top part there. So my fx plus h is x squared plus 2xh plus h squared plus 2, and then we subtract that with the original function. Therefore I'll put this in brackets plus 2. Okay, so now you can see that I have x squared minus x squared, therefore that will give me 0, and then 2 minus 2, that will give me 0 as well. Therefore I have the remaining part, which is 2xh plus h squared. Okay, so now let us move this top part here. Let us remove this part. Let us remove this part. Okay, so remember that this part here is x plus h minus fx is the top part. So let me just substitute there. So you have the gradient of the tangent line to be the limit as h approaches 0. Now we have this, which is in that case 2xh plus h squared all divided by h. Now if you do the direct substitution, you will get that you will have 0 and 0 whenever you remember that h approaches 0. So whenever I see h, I'll replace h with 0, and then I'll have something that looks like that, right? So this is what we call an indeterminate form. So we did this on our prior video. Whenever we get something like this, that means that we have to simplify further. So let me see here. The gradient of the tangent line in that case will be the limit as h approaches 0, and then if I take out h, because I notice that h here is common in all these terms, so therefore I can take out h as a common factor. Then I have 2x plus h all divided by h, and then I can remove the h because they are common, and hence I'll have the gradient in that case equal to the limit as h approaches 0 of what is remaining is 2x plus h. And then now I can do the direct substitution. Whenever I see h, I'll plug it with 0, so meaning I'll have 2x plus 0, and hence 2x plus 0 give me 2x. So that is my gradient, the tangent in that case. That is my tangent. That is the gradient of the tangent line, right? So now that we have m, how do I find c, right? Let's just substitute back. So remember, now we have y is equal to 2, or rather we haven't found my m, right? You notice that x is 1, right? So therefore I can say, well, 2 times 1 will be equal to mt, and therefore my m is equal to 2. Therefore if I substitute, I'll have y is equal to 2x plus c. Now the question is, how do we find the c? Well, we do have this point here. Remember that this point here is common on both of these two graphs, so I can use this point to find the value of c. Therefore my y is 3, and then my x is 1, and then you can just solve for c in that case. Therefore c will be equal to 1, and hence my function in that case is 2x plus 1, right? That's a complete function, right? That's an equation of the tangent line to that graph. So my answer here is y equal to 2x plus 1. Okay, now let us look at the let's look at number 2, right? Let us look at question 2. Okay, so question 2 reads as follows: find an equation of a line that is tangential to the graph given fx equal to 2x squared and parallel to the line fx 4x plus y plus 3, which is given which is equal to 0. Okay, so if you go ahead and sketch this one here, that function, the parabolic function, well, you can see that this here will bounce off the origin, where you have 0 and 0, right? And okay, let me just write it on this side, 0 and 0, right? And then this line here is parallel to the line that will touch this graph at a point. We don't know what point it will touch that graph. So let's see. Let's make y the subject of the formula here. So I'll have y is equal to negative 4x minus 3. Now from grade 10-9, we know that parallel lines will have the same gradient, right? Parallel lines have same gradient, so meaning if the equation line, or rather if the equation of if the line that touches this graph is parallel to this one, or rather is parallel to this one here, then that will mean they have the same gradient. We said that this here is my m, which is the same as the gradient, meaning the gradient of this tangent line will be equal to -4, right? So meaning my equation now is y is equal to -4x plus c. Now we need to find the c. That's a question, how do I find the c? Well, if I can sketch this one here, to be somewhere like there, right? Then meaning that line will bounce off somewhere there as well. Bounce off somewhere there. Should be touching the graph once, but oh my goodness. Okay, so let's say something like that. Yeah. Okay, it's not drawing to scale. Let's say these two lines are in parallel with each other. Okay, so now this is my function of this line that will touch this point here. So they will touch at some point at x, at an x value, of course, and some y value. Now we do not know those values, so we need to find those values. So basically here what I'm gonna do is, I notice that the again, we know that the gradient of this line here is given as the limit as h approaches 0, fx plus h minus fx, right, all divided by h. So in this case we know the gradient. We know that the gradient is -4, right? We know that the gradient is -4, right? So that means that, okay, if I can just find my f x plus h minus, or rather f, then wherever I see x, I will substitute this here, right? So meaning I'll have 2, then I have x plus h squared. Then if I expand the bracket, I'll have x squared plus 2xh plus h squared. Therefore, if you distribute the 2 inside, you will have 2x squared plus 4xh plus h squared. Okay, now let us find fx plus h minus fx. So in that case, we'll have 2x squared plus 4xh plus h squared minus this function here, which is 2x squared. Now you notice that these two here will move, because that will add up to 0, and hence I'll have 4xh plus h squared. That is now fx, that is fx plus h, and then minus fx, right? So now I can remove this part here. I can remove this part, and then I can substitute. Remember that the top part now is equal to that point. If I'll have the limit as h approaches 0 of this part here, which is 4xh plus h squared, all divided by h. Now this is equal to -4, right? Which is equal to -4. So now, if you like do the direct substitution here, when you let rather, you're gonna let this thing here equal to 0, you get, of course, the indeterminate form, which is 0 over 0. So if you have to simplify in that case. If you get 0 divided by 0, that means that you have to simplify. Therefore, the limit as h approaches 0, you take out f, or rather take out h, the common factor, then you're left with 4x plus h, all divided by h. Then you take out these two common here. Let's say this is equal to -4, and then you'll be left with the limit as h approaches 0 of fx plus h is equal to -4. And if you do the direct substitution, you will have fx plus 0 equal to -4. Therefore 4x is equal to -4, and hence x is equal to -1. That means that these two functions here, the tangent and the parabolic, they meet at x equal to -1, right? They meet at x equal to -1, and hence now if you find your y value at x equal to 1, you have to substitute that -1 into my original function to find my y value. So it will be, in that case, f1 rather -1, which is equal to 2 times -1 squared. That will give us 2, right? So meaning at -1 we have +2. So now that I have that, I can substitute it back into this equation here, to find the equation of the line, right? So I have my y is 2, and then -4 times -1, x is -1, and then minus c. Where did I get the 3? This should be minus c, right? So minus, or rather plus c. So how do I find c? Well, I will transpose this one to the right. If I have 2 plus 4 times -1, which is equal to c, so in this case I'll have 2 minus 2 minus 4, which is -2, is equal to c, and therefore the equation of the tangent line will be equal to y is equal to -4x minus 2, right? So that is how you tackle these average the average change, right? The rate of, the average rate of change. That is how you tackle these kind of question, right? So yeah, I'll catch you on another one where we'll be looking at the derivatives, some rules, and some properties. So yeah.